Hey everybody, Bill back here with you on Conrail Butler branch. So I thought I'd kind of try to just touch on the signals and signal control system that I'm using for the layout on the old Butler branch. So if you do see anything that you really like or interested or have questions, great opportunities coming up here at the National Model Railroad Association. They're putting on a show. The main show's the 19th and 20th of July, but the special interest groups, they're meeting from the 14th to the 19th. They're going to have clinics and displays, stuff like that. Especially the CMRI, if you look for the CMRI special interest group, be Scott Schrader from JLC Enterprises and Seth Newman from Model Railroad Control Systems. They're both sharing a table this year. They're going to be talking about computer model railroad interfacing, basically using a computer, to run the signals, I guess is probably the best way to put it. But if you look on my Facebook page, it's BHCRBB 2.0. Look that up. I don't think I have any filters, so I think anybody can get on there, but the links are on there for the National Model Railroad Association stuff. You can look up and see when they're going to be giving their clinics and stuff like that. But especially, if you're really interested in computer model railroad interfacing and stuff like that, signaling stuff, definitely a good seminar, good clinic to go and see and stuff like that. So we'll take a look at our signals and we'll pause it for a minute and be right back. All right, everybody, Bill's back here with you, and so now we're looking at an absolute signal here at Mexico. And there's a passing sighting. It goes from single track to double track. So the signals, the ground or the masted signals, they are showcase miniatures. At least the pole, the ladder stock, standoffs, all that is showcase miniatures. The finale and the base, they were 3D printed from JLC Enterprises, along with the signal heads. Those are all custom printed signal heads. They do have circuit boards in the back of them with surface mount LEDs on them. So the signal heads are actually prototypically sized. He also did the switch motor, the switch heater, and the propane tank. So anyhow, but then the apps, and then the signal bridges, as you can see, it's just a standard Bachmann, and we just mounted the move around here. Sorry about the shaky camera, but these are the JLC 3D printed signal heads. And as you can see, they're all specifically printed. So your left set of signals there has the clear approach stop in it, and the bottom one has the restricting. And then the other signal head, all it needs to do is display diverging diverging movements. So it'll display the restricting, medium clear, and medium approach. So anyhow, that's pretty much it. Here's all the signal aspects that we're doing. So you got the clear approach. This one here, the top, that's the stop. We don't display that. I mean, we do, but it'd be an intermediate, so it becomes a stop and proceed. We got to mount milepost markers on there. But once we do that, those signals up there will become a stop and proceed. They're intermediate signals. But then we also have the stop, and then restricting, approach medium, medium clear, medium approach. If it's got two red lights, it's an absolute stop. We don't have any dwarfs, but that's pretty much it. Those are all the signals that we display here on the Conrail Butler branch. So we'll take a second here, and we'll go in and we'll start looking at the control system. Be right back. And we're back. So basically I got a Dell box. I don't even know how old it is or whatever it is. I just got it used, and so anyway, we're using an old Dell box, and then of course we got our monitor, and this is the actual computer. This is in VB, Visual Basic 6. The program is done by Bill Carr. So there's a lot of extra bells and whistles on that, but that's what we're using for the software side is the VB6. So the basic hookup here is on the back here I have a 232 port. On the that's one of the benefits of using one of these old boxes. It's got a 232 port. So we run a cable off the back of the computer from the 232 port. We run across over here, and then we hook it into a 232 to 485 converter card, and it runs off of 5 volts, so it is hooked to 5 volts right there. And then down here, these are just they're just computer transformers, or whatever you call them. Yeah, computer transformers. One's 12 volt, one's 5 volt. The nodes take 5 volt, and the 485 card, it takes 5 volt. All right, and then the 12 volts, like my LEDs on my CTC panel, sorry about the burn your retinas out, but all these came from Amazon, and they had resistors on them, but they're all 12 volt. So I use the 12 volt up here for the LEDs on the CTC panel. So that's why I need the 12 volt in here. So anyhow, we got your 485 cable, or 485 card here. Scott is developing, or he's got a new card out, and he's actually getting it to the point to where you can actually, instead of having to have the 232 port, you can come off a USB-A, which is your standard USB port on your laptop, especially the older ones, and then it goes to a USB-C, which then that card would allow you to use like a newer computer, like a laptop or something, to run your signaling system. It go through that card and then come into your 485 card. Now, these are what you call nodes, all right? This is the Super USIC. This is Super USIC. The basic setup on a Super USIC, let's see if I can kind of get down here and get a little bit better view of it. So you have the motherboard, okay? And each motherboard has 15, I think it's 15 slots on it. Don't hold me to it. And this is actually, this one's actually 2 motherboards end to end, okay? They've been connected in the middle. So there's probably like 27 cards and input and output cards in here. And the reason for that is every one of these code buttons is an input. So all the little toggles, those are inputs. All the signal levers. Now signal levers, it's 3 position, but you only need 2. You ground it left or ground it right. And same thing with the switch. It's only 1. It's either grounded or ungrounded. For normal is ungrounded. For reverse, it's grounded. So, and then anything that has a light bulb in it, that's an output card. That's got to have an output. So every one of these light bulbs is hooked to an output card down here. And all these little code buttons and switch levers, those are all hooked to input cards down here. And your first board is always going to be your Super USIC card. That's the motherboard, okay? That's the one that's communicating with the computer. And then everything behind it is an input or an output card. So you just, really the key to it all is just documenting, is documenting it. That's the biggest thing, So down here where this is port A, pin 1. Well, the first thing I hooked up to was, let's just say it's this maintainer call. All right. So I just document, and as you hook things up to the input cards, you just got to make sure you write down what it went to. All right, and that's pretty much it. And then the computer just turns on and off and manipulates, you know, through this master card here on the front, the Super USIC card. But from the 485 conversion, from the 485 conversion card, now this goes from 232 is now 485, and in the book it tells you use 485 cable, which is probably looks like this cable here. It's a real heavy, usually has a gray on it. I just, you know, it's pretty expensive stuff. So I just used this communication cable that I bought off of Amazon. And there's about probably about 120 foot of it total. From here all the way to the last node on the layout. Scott, he came over and he hooked up his, he can check the wavelength on it, you know. So he hooked that up, and we didn't have any signal, anything interfering with the signal and stuff. So, you know, again, that's what I used. You know, I stay away from, you know, this 485 cable is probably about $2 a foot, 120 feet of it, if not more nowadays, with the way things have gone up. But yeah, I got two 60-foot rolls of this communication wire, and it seems to be working really good. So, you know, that's how I did it anyway. So we have 6 of these nodes. This is node 0, and it is here in the CTC room, and it only handles the CTC panel inputs and outputs. Okay, so again, the first 6 or 7 cards are inputs, and then the remainder of them are all outputs, and they're hooked to all the LEDs and stuff. So, but this is node 0. So here you can see, you know, the 485 cable comes in and then goes back out, and it goes to the next node. So we'll pause it and go check out node 1. All right, here we are. Got a little bit better lighting. I installed some strip lighting up under here, so we got a little bit better lighting here. So maybe we can kind of see what's going on a little bit better. So again, we have that motherboard, and there you can see some empty slots on the motherboard. You know, if you got, they also has S minis, which you know, it has, I think, 48 outputs and 24 inputs on it. So you don't have the extra cards on it. It's just one big card, and it does everything. But as you can see here, I've got quite a few cards in this node, so it would take several S minis. So basically, we'll look at this. So here we have our 485 cable coming in and then going back out, and it goes over to the other node. Again, we have 5 volt and 12 volt supplies hooked to this. I'm actually using it. It's actually over on the other side. It controls 2 aisleways. The power supplies are for 2 aisleways. And then there's you got to set the card address here, and that's in the book or the manual, or you can also access it on a JLC website. But node 0, all these switches are one way, and then you got node 1, which you flip one switch. So that differentiates this Super USIC card from any other Super USIC card. All right. And then again, we got inputs and outputs stacked in here accordingly. You know, I figured out how many inputs for this aisleway, how many outputs for this aisleway, and then I added in, you know, mounted those cards, and each one of those cards also has an address. You know, 0, 1, 2, 3, 4, 5, 6, on down the line. So you have to address those cards and put them in, and then it's basically. These are all inputs here on this front card. So inputs would be like toggle switches. Let me see here if I can find. Let's hold on here. So up here, well, this would be a good example. So up here, this would be an input, and this is a switch for the interlocking. This is for dispatcher call, and then this is for the other switch. This is another switch. There's two switches in this interlocking. See if you can see it there. I don't know. But anyway, so if the dispatcher gives local control to this control point, what happens is this is hooked to an input. So this is hooked, and then this is hooked to an input, and this is hooked to an input. And what you do is make sure you document that this is on port A, pin 0, port A, pin 1, port A, pin 2, and it's on card 1, okay? And if you document those, then the computer knows what it's hooked to. So when I do this, basically, I come off the ground, my common ground, or my ground, I run it out into this switch, and then run out of the switch down to that input card down there, okay? To the input card down there. So when this switch gets thrown, it sends a ground down to that input. Now the computer picks it up, goes, oh, hey, switch 55 just got grounded. So then what it'll do is it'll reverse the switch if it's in local control. But that's why it's not working right now, is because I don't have local control. Now, if I flip this one, okay, the system's up, it's operating. This is a dispatcher call. So if I want to contact the dispatcher, I flip this button, okay, it's hooked to it comes off the ground, into the switch, out of the switch, down to the input card, okay. Now the computer's picking that up. It's saying, hey, dispatcher 54 east wind coop switch has been thrown, okay? It's grounded. So now if we go in here, and we'll walk down here, if we go down here into the dispatcher's control unit, or control center here, all right, and that's a call light. Now if we look up here, all right, you see east wind coop lights lit up. Well, when I grounded that out there, the computer goes, oh, hey, I'm grounded. I need to turn this light on. So that tells me as a dispatcher, I look up there and I see that light, east wind coop lights on. That means there's somebody at east wind coop, this is where we're at right here on the CTC panel, okay? That tells me that there's somebody there wanting to talk to me. So then I'll call them on the phone. So if I look up here, and east wind coop's got the number 540. So I pick up the phone and I dial 540, and the phone will ring out there at east wind coop, and I can talk to my train crew out there. So that's kind of gives you an idea how simple it is. But a lot of it is just document where you hook stuff up, and then the software takes over everything from there on. It just basically, it's code saying, hey, if DS54 is grounded, then turn on that light, okay? So then the output cards, this is just my practice. This is just what I've always done. I always try to put my input cards at the head end. But these cards, in the program, you're going to tell them what order, whether it's input or output. You will assign different values, and all that stuff's covered in the manuals and the books. But, and it goes in groups of 4. So if you got an input, output card, it has a value. If you got an input, output, it has a value. And you'll put that in the computer, in the program, and then it knows what setup you have for that grouping of 4 cards, a value of that. And then it'll know that it has what order the cards are in. So you don't have to have all the inputs on one side or all the outputs on the other side. For me, it just made it easier. And stuff like that for that. Now, the output cards, again, anything that needs to be lit. Also, what it does, it also controls the switch machines. So you come off of an output. So if switch 53, it'll be hooked. I'll document what output it's on. All right, and then I run that over here. I run it over, and I hook it up over here. Now these are SMC 12s, and these are like really super cool. You only need one output line to throw the switch. And what these do is if it's grounded, it'll let the polarity go to the tortoise in one direction. If you unground it, this automatically flips the polarity, which flips the switch motor, the tortoise switch machine. So with one output line, you can control that switch. You can hardwire them into the outputs and then flip the inputs and outputs, whether they're grounded or not grounded, and it throws. But in case of anything happened, this kind of is a nice safeguard. These SMC 12s are a real nice safeguard. So you come in you come off your output card, and you come in over here, you tie in, and then you hook your switch machine. These two terminals over here, actually you hook it in here. This is your output coming in, and over here these are your switch machines, and you just hook your two wires to your tortoise and stuff like that. And so if this wire gets grounded or ungrounded, it'll reverse the polarity and either make it normal or reverse. So these SMC things are really cool. Again, Scott's making some changes. He is working on these cards, and so you can actually use one output to throw a crossover. So like here, you can see it comes in and it loops up. That one output is actually throwing two switches, which would be a crossover. So you got two tracks and a crossover. That one output can throw both of those switches simultaneously. So that's another really cool feature with those. Now, something you're not going to see is detection. All of my, at least for me, let me get up here. Let's see if we can find a detector. Well, poor planning, right? You know what I'm saying? So anyway, let's see if we can find a detector here real quick. And here's one right here. Okay, so I use these DCCODs. I tried some NCBD20s, but they were kind of janky. I didn't really like them. These have a capacitor, like a capacitance to them. So when a train enters the circuit, if you got dirty wheels or or maybe a resistor went bad on the wheel set of a car or something like that, these stay on a little bit longer. So let me see if I can hold the camera. And there's a little LED that'll display, show that'll come on. Let me see if I can get it to come on. Of course I can't. I need a car. Oh, there. Maybe you can't see it. Anyway, well. Oh yeah, it's on. Okay. I can't see it on the camera. But when I occupy that, you can see the LED. That's showing that it's occupied. If I let go, now the LED went off, so now it's not showing occupied. But it's got the tombstone on here on the DCCO. This is what they call a DCCOD. So there's a couple different ways to hook these up. I like doing it this way. They're out in the field, so the only thing I have to do is I have to give it 12 volts because it needs a 12 volt power supply to work. All right, and then you come off of your main bus. You come in here, it runs through the donut, it goes back out, and it hooks to the track. So when you occupy something, basically what this is basically like an amp meter type thing, okay? That's what I would think of it as. So it senses that there's electricity being used, okay? So it doesn't go into your track power. So if you short your track out or do anything like that, it will not damage this because it doesn't go into this card or interfere with any of these any other electronics. Okay, it's totally separate. That's one of the nice things about these DCCODs. And like I said, it does have it holds it occupied. So like I said, I tried to BD20 and it would flicker and stuff. So then when you look at your CTC panel, your OS light, occupancy light, it would flicker, stuff like that. These are a little bit more expensive. It does have an adjustment down here for sensitivity, so like when I laid out my track and I was test running and stuff, but then when I went back and I balanced it, you got moisture and stuff. Well, it made that conducted electricity. Some of these were stuck on. Well, I just turned this little dial right here and I could adjust the sensitivity back. And then once it dried out, then I could readjust the sensitivity again and stuff like that. But these are hardy. And like I said, that's a beautiful thing about the CMRI system is unless if you're using DC. Now I use DCC system. I use CVP products, Easy DCC. That's what I use for my control system, my carry control system. Now, they also do have, if you had a power supply, you got the old school power supply with the the forward backward and the old MRC power pack. They also make another detector for that, and it's called an OD. So you can use those OD. They use the ODs for if you had like a power pack or MRC power pack, or there's another system, and it's made I can't think of it right off the top of my head, but they do use DC track power still, so you would have to use ODs. But this would work with Digitrack, Digitrack systems, NCE, Easy DCC, CVP products. It would work with this particular detector works with all three of those manufacturers, and that's what you want. But again, like I said, you got your 12 volt coming in. There's 5 wires. Your 12 volt, that'd be the red and the yellow. And then I just bring a black wire in, and then bring a black wire back out. That runs it through the donut, and that's in between your main control bus and your track is what it is. So anything that enters there, if it uses electricity, that donut will pick it up and it'll sense it, and then it'll trip. And then what it does is it sends a ground, okay? It sends a ground signal back to the input card down there, all right? Down there on the DCCOD, or on the node, the input, it sends a ground signal down there, and the computer picks it up and goes, oh, hey, this section of track just became occupied. Well, then it turns on the panel light showing occupancy on the CTC panel, but that's all software stuff there. This is what we're looking at right today, is just the hardware side of it. We're just looking at how's this work, what makes this tick, and stuff. So I like to have mine. I like to have my my detection out in the field. Otherwise, if I had these on a motherboard down there, I say I got 24 blocks in this aisleway. This is a 40-foot aisleway, double level. So let's say I got 24 blocks between OSs and blocks and everything. I got 24. Now you can take, and they got motherboards, and you can put those detectors, plug those detectors straight into there. But then I have to run a wire from this block all the way across here, down here, over there, into it, and then run another wire out of it, and then back up and over here and onto the track. Or I guess I could have all my power down there and hook it to that. But I still have to run a long wire all the way up here and then hook to the track. So I like to just hook my track power up here. It's a short distance, a short little stretch of smaller wire, and then just run my ground wire from here down to there. So it's probably one way or the other, right, wrong. But anyway, that's how I hook up my DC CODs. I leave them out here in the field, and then I just kind of tuck them up or strap them up out of the way, and that part of it. So so there you have kind of that is node 1. Signals, basically you just come off the signal and you come down, and again, it's documentation. If you hook the green, to card 7, port C, pin 1. And then if you hook the approach up next, then it's, you just keep going on, card 7, port C, pin 2, and then just keep building on that as you hook the signal up and document that. That way the program can turn on and off those outputs. That's all it is their light switch. That's all it's doing is turn on off light switches. So it turns the green, if you got a clear signal and the train goes by the signal, the computer turns off, it turns off card 7, port C, pin 1, and it turns it to red, which is, card 7, port C, pin 3. Okay, so that's how it does it. All the software takes care of all that. So on the hardware side, as long as you document where you hook everything up and in the order that you hooked it up on each card and each port and pin, excuse me, that pretty much really makes the hardware side pretty easy. We won't get too much into the computer programming, but at least not right now, because that's a whole different, and that's if you can go to the National Model Railroad Association thing, that's great. You get to see the hardware, see how it works, how it hooked up, and everything else like that. But this is node 2. We won't spend a lot of time on here. Now here, like I said, we got, excuse me, the 2 power supplies, 12 volt, 5 volt. This is a 12 volt. That's just for street lighting. And then, like I said, so then, but then this is another node. You can see here. I still stayed with a Super USIC, Now, if you wanted to, you can use an S Mini. That would be the only thing that I know of. I mean, I don't know a lot about Seth stuff, but you could take this and instead of having one big thing, you could take a output or a S Mini. Let's see if I can find a good location. Well, here we got the start. So you could actually put an S Mini up under here, and so for every light on a signal, it counts as one output. So if you got red, yellow, green, that's 6 outputs, and then that would be, say, 6 outputs, and then over here you got another signal. Maybe it's 3 light over 3 light. So now you got 18 outputs. Okay, you're going to need an output to throw the switch. All right. I have these. So these are call-on lights. All right. So if the dispatcher wants to talk to me, this light would be hooked to an output. Okay. So you can kind of see an S Mini. You could put it in an area, certain area, or a certain location, and you could hook everything to it. And then you just run a 485 cable over here, around here, to the next location. All right. You could hook up because it has inputs and outputs. So here we have dispatcher toggle and a switch toggle. If I had local control, I could throw this. And so this would be hooked to an input on the S Mini, and this would be hooked to the input on the S Mini. Maybe I'm going to get this block detector, okay? I'm going to hook up this block detector, this OS block detector, and this OS block detector, and that OS block detector. I'm going to hook them all to this one S Mini here. So you can spread S Minis around. I just like, myself, personal preference, I just like to have basically everything located in one location and run the wiring to it. I use just the most of my wiring for all my signals and stuff. It's just, all it is it's Cat 5, Cat 6, Cat 5 wire, as you can tell from a lot of the hookups on there. So kind of speed it along. So you got, that was node 2. You got node 3 down there, and node 4 is down there. So like this signal right here, you know, to give you an example. So this signal right here, it is, you know, this is actually just hooked up directly, okay, to the 12 volt or 5 volt. 5 volt, I'm sorry. This is hooked directly to the 5 volt. All right. So all I need is to make this signal work, I need 3 wires, okay, to go back to the output down there. So if I'm using Cat 5 wire, Cat 6 wire, all right, that has 8 wires in it. So I take 3 of the 8 wires and I hook it up to here. And then I document, okay, I used the solid green, the solid brown, and the solid orange. All right, and I hooked them up, so green is green, orange is yellow would be, and then maybe the red would be the restricting on this signal. All right, so then I document, so I hook those wires to here and I hook them down there to the output card, and I document what signal it is and I document what signal it was that I hooked up. So this is signal 28. So this is interlocking. This is control point 28. So this is 28R signal, okay, because it's controlling for a right-hand movement. So this is a 28R signal. So, and that's the other thing, you have to document, you have to note what everything is. So that's 28. So then you might, over here, you got 28LA, 28LB, and then 28LC. Okay, so left movement, this is the A signal, the B signal, and the C signal, okay? And it's a little bit more involved in that, but that kind of gives you the gist of some of the stuff that you need to kind of, when you're doing this, that you need to kind of think about. You know, you have to assign. So this is control point 28. So you're gonna have right signals, left-hand signals. You might have multiple signals going the same direction. So you got an LA, LB, and LC. Okay, so that's just kind of a general thing there. But anyhow, kind of lost track of where I was going with it. But anyway, we got down there. So, you know, I guess that's what I was kind of pointing out. So yeah, I got a long 40-foot wire going all the way down there, and goes down there, and then goes in and hooks down there. So that one cable, it's doing 3 on this one, and then maybe this only has 4. So you got this signal can display stop, approach, clear, and restricting. So there's 4 right there, right? So I got 3 from there, 4 from there. That's 7 outputs, and I got an 8-wire cable, right? So what I do then is, well, I got to have a call light, right? This dispatcher. So then I hook the 8th wire to there. So with one run, I took care of that signal and this light, okay? So then we come over here, and I got, there's 3 aspects here and 3 aspects here, restricting, medium, clear, medium approach, same thing for this. So there's 6 right here, all right? So there's enough. So now I'm on my second run of cable, all right, down to here. and I hook up those, document how I hooked them up. I got solid, 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 stripe, 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 and green, orange, brown, okay? If you ever look at Cat5 wire, you'll know exactly what I'm talking about. So this would be all the solid ones, and this is all the striped ones. They're okay. So that's how I do that. All right. So now I have 2 extra cable. So I have 2 extra wires. Now I may not use them, but what I did was then I got a switch machine. So 2 of those, there's a blue set in there. And a lot of times what I would do is I would use the extra blues. The extra blue wires, I use those for switch machines because you need 2 wires to run from here down to the SMC12. And again, you could run 1 wire up here, cut up that SMC12 into chunks, hook the ground to it, and then but then you could just come right off of it. So you could actually use the 2 blue wires if you put the SMC12 here at this location. Those 2 blue wires, you could use one to control this switch, and then one to control this switch right here. So you got everything covered. But there again, so this does probably got an extra cable in there with about 6 cables that I didn't use. Or what I would do is I cut it out of the sheathing down here and pull it out, and I use it for this signal right here, or this signal, whatever. But that's kind of how I hooked everything up. I mean, it looks like a big jumbled mess of garbage, and I know there's some electrical engineers and people just absolutely losing their minds right now with all the wires dangling. But like I said, with good documentation, with really good documentation, you can see here, so like if we get back, these are the outputs. So you can see that I actually tagged. So this is 14. That says 14 on it, right? So that's OS 14, okay? This is OS 18. That says 17. Usually your OS is OS, and then that's 11. All right. So now if we go back here, and so we had OS 14, right? So I know that cable runs, here's CP14. So I know that cable is hooked to probably this set of signals here, okay? All right, so, and then we'll talk about maybe some other stuff. When you get double crossovers, let's look at this scenario here. Okay, so this scenario here, there's only 2 OSs here, or 2 control points. The back track, and the front track. All right, you only need 2 detectors for this whole interlocking right here. You only need 2 detectors. Now, depending on who you talk to, oh no, you got to put 1 on each switch. You got to put 1 on this and 1 on this and 1. That way you know if the switches are occupied, blah, blah, blah. But look, a little common sense. If there's anything on this track from this signal clear down to this signal, if this switch is occupied or that switch is occupied, you can't do anything. You can't throw any switches. Same thing with this track. If there's anything on this, anything from here down to here, whether it be over here or over here, it doesn't matter. If these 3 tracks up to here or this over up to there, if any of that's occupied, you're not going to be able to do anything. You can't throw any switches. The only reason you have the 2 OS or the 2 detectors in there is if you have a movement on the back track this way, and maybe you got a movement on this track this way on the front track. All right, then it needs to know if it's occupied or it's not occupied. You need to know that that OS is occupied or control point's occupied or this control point's occupied for the programming aspect of it. So anyway, that was node 4 down there, and so that is node 4, and then down here we have node 6. All right, is node 6 right there. It's right there. As you can see, it's not a lot on it. Just a few input and output cards, because all that node 6 does is each one of these are an input. So when I push on a button, all right, it just lined all these switches for that track. All right, it's automatic. It's just push a button. Okay, when I do this, there's a ground wire. It comes into this toggle, and then goes out, and it goes down to an input card down there, an input pin, and that tells the computer when I push that, oh, this pin has been grounded. Then the computer throws the switches and turns this light on to let me know that I aligned myself into this track. You know, so this is just for the yard. All right, and I don't know if you can hear the switch machines throwing, but you know, both yards are set up like that. All right. Now, the other thing is we'll look at like, let's see if we can find, so the other thing I do is, I don't know if I can get a good look at this, but I telephone line everything, okay? So the red and the black, okay, that is my DCC system, okay? The green and yellow, the green is ground for 5 and 12, and they need to be hooked together, okay? So you need to hook your 5 and your 12 volt ground to this green wire. This yellow one, all right, is my 12 volt positive, okay? And then, we got a brown, the blue one is a 5 volt positive, okay? So you got 12 volt positive, 12 volt positive, 5 volt positive, and ground, okay? Those three right there. Now you'll see extra black wires in here, okay? And that gets into your DC, the reason there's one of these rails you have to hook your DCCOD into, right? So I followed the recommendation. I did not solder. Let me see if I can find a joint here real quick. Right here, here's a joint. All right, so I put a credit card in there. So I put I laid this section of track, I put a credit card in there, and I laid this section of track. Okay, so there's a gap, expansion and contraction gap there. So if I get any expansion, if my rail starts to move, all right, if it gets really warm up here, and you know, that's going to cause your rail to run. I mean, it's going to expand. Well, what it'll do is it'll close that little gap up. If it gets really cold up here, then what'll happen is the rail will contract and it'll open up, okay, and it'll leave a little bit bigger gap than what's there. All right. But when you do that, you can't always guarantee electrical connection through this joint now, okay, because it's not soldered together. So what you have to do is on one rail is your common rail. You can hook it, so that's the red wire. So the red wire, so you just go through and you hook this straight to your bus line and this straight to your bus line. But what you have to do with the DCCODs, because you know this is 12 foot, there's from that signal to that signal down there, there's 12 foot of track. So there's 4 3-foot pieces of track in here, right? So that means I got a drop feed over here, one here, and one right here. Well, what you have to do is you have to take all 4 of those and connect them, all right? Run it through your DCCOD, and then back to the black wire. I use black. You can use, so the red one, you just, as the drop feed, just hook it to red. But this front one's a black wire, so then I got to hook up all 4 of those, then put my DCCOD in between the 2 of them for detection, and then hook it to the main black wire going across. And that's why when you look up underneath of here, you'll see that I have 2 black wires right here, and there's a black wire over there. This is the main bus, okay? This is the main DCCO. This is the main main bus, these two right here. These hook up all the individual drop feeds. Then it goes, you can see right here, it hooks up to this drop feed right there. See how it's just hooked to it? Then down here a ways, you're gonna, if we went, let me see if I, oh, right here it is. As a matter of fact, right here it is. It's kind of in a jumbled up mess. But now what I have to do is I have to come off of, one of them's the front, one of the black wires is the front track, and the other black wire is the back track. So I have two detectors up here, one here and one here. So I have to come off of this wire, go into the detector, come back out, and go to this black wire over here. So that way, if anything enters that block, let's see if I can get it to work. Right there, okay? If anything enters that block, all right, it'll detect it. All right, if I do the other track, that detector comes on. All right, so some things kind of keep in mind is, you know, as you're laying your track and stuff, keep in mind that you're going to have to run one of these line tracks is probably going to have to be double ran. You're going to have two black wires. You'll have your main feed and then the feed that picks up all the drop feeds, okay, and then runs through the detector. So that's kind of how I did the track work, you know, as far as detection on that. Anything else? Let's see. Not really thinking anything else. But like I said, that's how I'm doing it. Probably not 100% right. I know there's a lot of people pulling their hair out. Oh, well, let's go one more thing here. Since we're almost an hour long into this, might as well make an even hour, right? Okay. So let me see if I can find, oh, here's a perfect one. Industrial switch. All right. All my industrial switches are just hooked. Remember, we ran that 12 volt bus, right? We got 12 volt positive and 12 volt 5 volt negative. All right. I just come off of that, go into a double pull, double throw toggle, right? You know, so I can throw the switch back and forth. Okay. Has nothing to do with the dispatcher. Now, what you do want to do though, okay, and don't tell anybody this is a cheater method, okay? But what you do is you come off your ground wire, all right, your green. You run it into your tortoise switch machine. Well, no, cancel that. I'm sorry. I'm telling you wrong already. No, what you want to do is, say you got your red wire back here with a drop feed, okay? You hook into that. You run it into your tortoise switch machine. So when the switch is, and what you want to do is you want to reverse it and find out that the two contacts that the electricity's flowing, that it makes the circuit, right? So you come off of this feed, go into your tortoise switch machine, come out of your tortoise switch machine, you put about a 10K resistor on it, and you hook it to this feed. Now, what did we just do? Now we just created a circuit, right? Because it's coming off this drop feed, going into the switch machine, going through the switch machine, coming out, going through a resistor and hooking to this drop feed on the opposite rail, right? So now we created a circuit. So what's happening is that's picking that, it's picking that up. So what'll happen is it will drop the signals at each end of that block. All right. It'll drop those signals. And if you go in and you look at your CTC panel, you'll see this section is occupied, okay? Because you basically shunted the track. You basically made it like there's a train there, all right? So now what happens is this way, if this switch gets left open, okay, that intermediate signal down there coming this way into this block will be a stop and proceed. It'll be, okay, it'll be a stop and proceed. So I'll have to come restricted speed up here looking out. And they get up here and they go, crap, switch is bad. They'll stop. They'll restore the switch. They'll go up to the next signal. Well, they got to clear, so they blast on, right? So that's a little cheater method is what you're doing is you're shunting this. When you put this in reverse mode, you want to shunt that circuit. You want to put a load on that with that resistor. That's what you're doing, okay? And or you can get fancy and you can run wires from here to input, and then write in the program that if the switch is in reverse, then show circuit occupied and turn this. Or you can just shortcut it, come off this track, go into the tortoise, come out, go put a resistor on there and hook it to the other track. It will shunt the track when the switch is in reverse and knock the signals down and give restricting and leave a track light on. So the other thing is the dispatcher will go, hey, I got a track light on there and I don't have any train in there. So he'll call the maintainer. The maintainer will drive out here and he'll cross the track and he'll come up here, and then he'll stop and pull off in the weeds, and then he'll walk over there and he'll see the switch is reversed. He'll unlock it, throw the switch back into normal position, lock it up, go back over, get on his truck, and he'll radio the dispatcher, hey, that track light clear up? Yeah, it's gone. Okay. And that's it. So anyway, thanks for hanging with me, and hope you guys have a great weekend. And I guess since I got the layout fired up, maybe I'll run some trains. Oh, I guess we'll do one more thing. So you can kind of see, here we go again. So we're going to use a phone system. Yeah, I got 4 minutes left. So we got 4 minutes to the whole hour. All right, so here, this is going to be our phone system. So we're going to have phones at all these control points. We're going to have phones hanging down here, at all our control points. So anyhow, they will hook into this, and this will hook into the dispatcher's office. So we're going to be working on this here pretty soon, getting this. Scott hooked me up with this, but we're going to be installing this for the phone system. So once we get the phone system in, we're going to be pretty well good to go on that. So if you watch the train operation video, so here we are now. Let's see if I can get a good picture of this. So this is what you'll get when you get here. Consolidated Rail Corporation train sheet. All right, it has your train ID, description of what you're going to do. Then it'll go station. So on this particular job, so this is the UBU. This is this is the ethanol train. Okay, so that is let's see, right over here. So we can kind of put it with it. All right. Okay, so but this is a formal paperwork, and I got probably about 2/3 of these done. I think we got about 40 trains to do, and I'm getting up there. So we're moving along with the paperwork side of it. But anyway, here you're gonna come light power, loaded ethanol train from Bioprice and Butler. Okay, so to Butler, power out of Logansport yard east to Mexico, which Mexico is actually the control point right there is Mexico, and we're right there is where we're talking about. All right, so anyway, we're gonna get light power out of Mexico to Butler Yard, or we're gonna get light power out of Logansport. We'll go to Mexico, shove into industry, tie on to track 3. Okay, so the back track is 1, 2, and 3. So we're going to tie onto the buffer car. It says buffer car. Tie onto a buffer car and pull 7 cars out. So 1, 2. So there's buffer car 1, 2, 3, 4, 5, 6, 7. Okay, so we got all 7 of them on that track. So we're going to pull those out, and then we're going to double to track 4, 3 tanks and a buffer. So track 4, 1, 2, 3, and a buffer. Okay, so we're going to pull out that cut of cars and double it to this cut of cars, right? All right, and this is the cars. So So let's look at the last car should be a BNSF car, okay? Because since the other one's behind the building there. So our last car should be a BNSF 433246. And that is a BNSF car. And it is the right car. All right, so that'd be our rear car there. So now we've completed this upper part of the train sheet. All right, now station Butler yard, contact Butler yard master for a track. So here we depart Mexico, and we're gonna go down, around, down, back up, back down, back up, and then we're going to go in the helix, go to the second level, come all the way around here, all the way around here, all the way around here, up and around, and into Butler Yard, which is here. All right, so station work complete, you're done. So that is, the paperwork's coming along. We get the phone system and the rest of this paperwork up and going. We're going to be operating, boys and girls. So hold on to your booties. So anyway, that's where we're at as far as operations. So appreciate you guys. Hour's up. Sorry about wasting an hour of your time. But hey, you guys have a great day. And thanks for watching. Bye.